angle measures and angle bisectors. Constructing a copy of an angle. Start with a point X and use a compass and straight edge to construct a copy of angle S. Use a straight edge to draw a ray within point X. Place the point of your compass on S and draw an arc that intersects both sides of the angle. Label the points of intersection T and U. Without adjusting the compass, place the point of the compass on X and draw an arc that intersects the ray. Label the intersection Y. Place the point of the compass on T and open it to the distance TU. Without adjusting the compass, place the point of the compass on Y and draw an arc. Label the intersection with the first arc Z. Use a straight edge to draw XZ. Angle X is a copy of angle S. If you could place the angle you drew on top of angle S so that ray XY coincides with ray ST, what would be true about ray XZ? Explain. The ray XZ would coincide with the ray SU. Is it possible to do the construction without a compass that is stuck open to a fixed distance? Why or why not? No. You could make the arc to create U and T, but you would not be able to adjust the opening like is required in step D. An angle is a figure formed by two rays with the same endpoint. The common endpoint is the vertex of the angle. The rays are the sides of the angle. Draw or name the given angle. Angle PQR. When an angle is named with three letters, the middle letter is the vertex. So the vertex of angle PQR is the point Q. The sides of the angle are two rays with common endpoint Q. So the sides of the angle are ray QP and ray QR. Draw and label the angle as shown. The vertex of the angle shown is point K. A name for the angle is angle K if we're just using a single letter. The vertex must be the middle, so more names for the angle are K in the middle and J and L on both sides. Or we can reverse the order of L and J. The angle is numbered, so another name is angle 1. Without seeing a figure, is it possible to give another name for angle MKG? If so, what is it? If not, why not? We can. We know that K is the vertex, so we can change the order of the remaining two letters. Use the figure for 4 through 5. Name angle 2 in as many different ways as possible. This can be angle BEA, or we can change it so it is AEB. We would not want to just name it angle E because that could be referring to number 2, number 3, or number 4, or this angle on the back side. So we need to at least use 3 letters in this case, or the number. Use a compass and straight edge to copy angle BEC. Start by drawing a ray. Then you're going to draw an arc over angle BEC, making sure you intersect both rays. Then swing that arc on the ray that you just drew. It doesn't necessarily need to be a full circle here, but it does need to be wide enough to get both of the rays. Then you're going to open your compass up to the distance of the angle, or between those two points of intersection. And then you're going to swing that arc from the point where your circle intersects the ray that you drew. Now where those two arcs intersect is where we need to connect our line. Now this is the same size as the angle BEC. It is oriented a little different, but they are the same angle. The distance around a circular arc is undefined until a measurement unit is chosen. Degrees, notated with that little circle, are common measurement units for circular arcs. There are 360 degrees in a circle, so an angle that measures 1 degree is 1 out of 360 of a circle. The measurement or the measure of an angle is written as M with the angle symbol A, or if we're naming it with 3 points, we could say the measure of angle PQR. You can classify angles by their measure. We have acute angles, which are between 0 and 90. We have right angles, which are 90 degrees. Obtuse angles, which are 90 to 180. Straight angles, which are 180. And then there's also something that's called a reflex angle, but we don't see that very often. And those are angles that are over 180 and less than 360. Use a protractor to draw an angle with the given measure. This one, they are drawing a 53-degree angle. And so they're going to walk you through the steps. To start, use a straight edge to draw a ray XY. Then place your protractor on the point X as shown. Locate the point along the edge of the protractor that corresponds to 53 degrees. Keep in mind that there are 2 spots that can be labeled with 53. Here and here. We know that 53 is an acute angle, so we want to make sure that we choose the 53 that would create an acute angle. So they've chosen the point Z. Then we draw connecting X to Z, and the measure of angle ZXY is equal to 53 degrees. It is now our job to draw the 138-degree angle. That is an obtuse angle, so when you choose which piece of the protractor to use, make sure you are pointed at the one that will create an obtuse angle. Use a straight edge to draw a ray AB. Step 2, place your protractor on point A so that the ray AB is at 0. Locate the point along the edge of the protractor that corresponds to 138 degrees. Make a mark at this location and label it point C. Draw ray AC so that the measure of angle CAB is equal to 138 degrees. Explain how you can use a protractor to check that the angle you constructed in the Explore is a copy of the given angle. We would measure the given angle and the constructed angle, and they should have the same measurement. Each angle can be found in the rigid frame of a bicycle. Use a protractor to find each measure. You will line up the point N on 0 of the protractor, and the ray NP should be in line with your protractor, and you will find that the measure of angle MNP is 40 degrees. You will also make sure that K is in the center of your protractor and the ray KL is in line with 0. then you should see that JKL has 105 degrees as its measure. Constructing an angle bisector. An angle bisector is a ray that divides an angle into two angles that both have the same measure. In the figure, ray BD bisects angle ABC so that the measure of ABD is the same as the measure of CBD. Both of these angles have the same measure because this ray divides it into two, it bisects it. The arcs in the figure show the equal angle measures. If S is in the interior of angle PQR, then the measure of angle PQR is made up of the measure of PQS plus the measure of SQR. In example 3, they are going to walk you through how to use a compass and straight edge to create that angle bisector. It says, use a compass and straight edge to construct the bisector of the given angle. Check that the measure of each of the new angles is 1/2 the measure of the given angle. Step 1 is to place the point of your compass on M and draw an arc that intersects both sides of the angle and label it with P and Q like you see here. Then place the point of the compass on P and draw an arc in the interior of the angle. Without adjusting the compass, place the point on Q now and draw an arc that intersects the arc you just drew. Label the intersection of the arcs R. Use a straight edge to draw the ray MR. The measure of these will be the same. Down here in step 5, it says, measure with a protractor to confirm that PMR is equal to QMR and that they are both half of the original angle PMQ. And it shows that the original angle was 54 degrees and both of the angles they created are now 27, which is in fact half of 54. In B, we are going to do these steps on our own. Step 1, draw an arc centered at A that intersects both sides of the angle. Label the points of intersection B and C. I'll do that part at the end. Step 2, draw an arc centered at B in the interior of the angle. Step 3, without adjusting the compass, draw an arc centered at C that intersects the last arc you drew. Label the intersection of the arcs D. Draw ray AD. Check that the measure of angle BAD is equal to the measure of CAD, which is half of BAC. The original angle BAC was 90 degrees, and D crosses at 45 degrees. Explain how you could use paper folding to construct the bisector of an angle. We could fold the paper so that one side of the angle is on top of the other, and when you unfold it, the crease is where the angle bisector is. Use your compass and straight edge to construct the bisector of the given angle. Check that the measure of each new angle is 1/2 the measure of the given angle. Start by drawing an arc intersecting both rays of the angle. Then open your compass and draw an arc from the point of intersection. Then leaving your compass the same size, put it on the other point and swing the arc. Then draw a ray from the vertex of the angle through the point of intersection. For number 11, open your compass to swing an arc through both of the sides. You can readjust your compass at this step. Then you'll swing an arc. Make sure you do not change your compass from here. Leave it the same size and swing that arc. And complete the angle bisector by drawing a ray from the vertex through the two blue intersecting arcs. 12. What is the relationship between a segment bisector and an angle bisector? A segment bisector splits a segment into two parts, and those parts have the same length. An angle bisector splits an angle into two equal measures. 13. When you copy an angle, do the lengths of the segments you draw to represent the two rays affect whether the angles have the same measure? Explain. Rays continue forever in one direction, so the length we draw them is just a piece of the ray. And angles are a portion of a circle. Many protractors have two sets of degree measures around the edge. When you measure an angle, how do you know which of the two to use? I look at the degrees that it gives me to determine if it's acute or obtuse. If it's acute, I use the angle closest to the existing ray. And for obtuse, I find the measure that's farther from the ray.